section 1.4, separation of variables method. Basically, we already discussed this method in section 1.2. Let us start with this example. Note that what we see here is not first order linear differential equation because we have y squared. What do we do? Well, as we discussed, we can think about this as about a normal algebraic fraction. Well, first of all, the left-hand side is y prime. But can we think about y prime as about a fraction? The answer is yes. If we think about dy as about a differential. So, we think about this as about a normal algebraic fraction. Next step, move dx to the right and y squared to the left. Done. Note that now we have only y terms on the left, no x terms. And we have only x terms on the right, no y terms. Which means we just separated the variables. Equations where we can separate the variables are called separable equations. Not every equation is separable. For example, if instead of x squared or y squared we have, say, x squared plus y squared, this equation is not separable. Here we are talking about separable differential equations. So, step 1, we separate the variables. Step 2, one can show that we can integrate both sides. Done. After that, antiderivative of y squared is 1/3 y cubed. Antiderivative of x squared is 1/3 x cubed. And we put plus c only once. Here's why. Well, we can put plus c1 on the left and plus c2 on the right. But then, if we move c1 to the right, we will get plus c2 minus c1 on the right. And if we denote c2 minus c1 by capital C, we'll get exactly what is written here. So there is no need to put plus c1 on the left and plus c2 on the right. Just 1 time plus c on the right. Next step, multiply both sides by 3 and take cubic root. We get this. Very last thing, if we denote 3c by k, we get exactly what is written here. Folks, any questions here?
Is there no plus or minus sign?
Since we take cubic root, we do not put plus minus. If we have y squared here, we put plus minus.
Yes, sorry, I forgot.
For 3c, can we not just say that equals c?
No, we can't, because 3c is equal to c is an equation. 3c is equal to c only if c is equal to 0. Here we have to use a different letter, or if you wish, you can use lowercase c.
Okay, thank you.
Any other questions?
So, Professor, in the cubed root, we could either write plus k or plus 3c?
Yes, absolutely. So here you can jump from here to here immediately. Y is equal to cubic root of x cubed plus k. Just don't put here plus c. If you put here plus same c as before, this is a mistake.
Okay, thank you.
Any other questions?
So I have a question for you.
Yes.
When we're dividing by y, do we have to keep in track of what if y is equal to 0?
Excellent question. Note that here we do not divide by y. It's originally written x squared over y squared. Therefore, by default, y is not equal to 0, therefore there is no need to split into cases. Excellent question.
So if it wasn't the case, then we would have to
Yes,
split it into the two
absolutely.
cases.
And this will be discussed later over here. The
Okay.
original equation is this. And if we apply the separation of variables method, in order to separate the variables, we have to divide by y, and therefore we split into cases. Y is not equal to 0 and y is equal to 0. Here, there is no need to do it.
Okay, thank you, sir.
Next example. What if we have the following initial value problem? This equation and the following initial condition. Well, here's what we do. Since y of 0 is equal to 2, we replace x by 0 and y by y of 0. So this becomes this, because x cubed disappears. X cubed, since x is 0, is 0. Next, y of 0 is equal to 2. So we replace y of 0 by 2. Done. And then we cube both sides. K is equal to 8. Conclusion. This initial value problem has the following solution. Y is equal to cubic root of x cubed plus 8. We just replace k by 8. And now look at this picture. Since we can plug in infinitely many numbers instead of k, we can plug in any real number instead of k. We have infinitely many curves here as graphs of the corresponding functions. But if we have an initial condition, we pick just one curve, which is the graph of this function. So in our case, it's this pink curve. Folks, any questions about B?
So when there's no no y x value or like a certain value, like you can choose any of those curves.
Yes, absolutely, because k can be any real number. For example, if k is equal to 0, we have y is equal to cubic root of x cubed. And after simplifications, it becomes y is equal to x. The graph of this function is this straight line. Obviously, here we have few out of infinitely many curves. So if k is not equal to 0, we have a curve that is similar to one of these curves or one of these curves. Any other questions?
So since the 3c and k are equivalent, if you were to plug in, let's say you didn't use k and you used 3c for the initial condition, would that be incorrect? Because then you would get a value of 8/3 instead of 8 if you were to use k.
If you use this formula, then c will be 8/3, but 3c will be 8 again, and we'll get same result.
Okay. Thank you.
Few more examples. Here, again, it's a separable equation. We move this to the left and this to the right. Done. We integrate both parts, and then antiderivative of this is over here, antiderivative of this is over here, and we put plus c only once. We don't do anything else, because what is written here cannot be rewritten in an explicit way. Here's what I mean by explicit way. Explicitly means only y on the left, and then on the right we have some expression on x only. This cannot be written explicitly because the left-hand side is too complicated. So we leave the answer in an implicit form. Folks, any questions about this example?
So for that question, if we have an initial value, can we write it explicitly? Like if
No, if we have some initial value, then we assign a certain value for C. But
Okay.
it does not really mean that we can rewrite this as y is equal to ta ta ta.
Okay. Thank you.
Last example. Please take a look at this equation. Actually, here we do not need the separation of variables method. The easiest way to solve this equation is to recognize a first order linear differential equation, moreover homogeneous. So if we move this to the left, we get this. And now a of x is equal to negative x squared. So we replace a of x by negative x squared, done. Minus times minus is plus. Antiderivative of x squared is x cubed over 3. The problem is completely solved. This is the general solution of our equation. However, we can apply the separation of variables method. But now we have to consider two cases. Case 1, suppose y is not equal to 0. We divide both sides by y, done. Actually, before that, first, in order to apply the separation of variables method, we have to replace y prime by dy over dx. Then, we divide both sides by y, done. We integrate both sides. The left-hand side is ln of absolute value of y. The right-hand side is x cubed over 3 plus c. Then we raise e to the left-hand side and to the right-hand side. Done. Note that e to ln of absolute value of y is simply absolute value of y. Over here, we split this expression into the product of two expressions. And lastly, since here absolute value of y, we rewrite this as y without absolute value is equal to plus minus this expression. So, if y is not equal to 0, the general solution of this equation is this. But now, what if y is equal to 0? Well, observe that if y is equal to 0, this is a solution of our equation, because 0 prime, which is 0, is equal to x squared times 0, which is 0 again. So, if y is not equal to 0, we have this. If y is equal to 0, this is again a solution of our equation. Can we combine these two formulas together? Yes, and here it is. Now, capital A is any constant, 0 or positive or negative. If A is equal to 0, we get this. If A is not equal to 0, we get this.
So in which case is it absolute value and in which case is it plus or minus again?
Well, note that over here we have absolute value, because here we have absolute value, because antiderivative of 1 over y is ln of absolute value of y. So here we have absolute value, here we have absolute value, but then over here there is no absolute value, here we put plus minus. So if we skip absolute value, we put plus minus. Think about the following. If absolute value of y is equal to 5, y is equal to plus minus 5. Same as here, absolute value of y is equal to this. Therefore, y without absolute value is plus minus this expression. Was that your question?
Yeah, that makes sense because it can be either or. Okay.
Yes. Other questions?
Yeah, really quickly, could you go over the situation where y equals 0 again?
Yes. So, suppose y is equal to 0. Then we cannot apply this logic, because in order to jump from here to here, we divide by y. If y is equal to 0, we cannot divide by y. Then what do? Well, we apply a fundamentally different approach. We just observe that y is equal to 0 is a solution of our equation. How to know it? Well, just plug in. Replace y by 0 here and y by 0 here. 0 prime is 0. X squared times 0 is 0. So the left-hand side is equal to the right-hand side if y is equal to 0. Therefore, y is equal to 0 is a solution of our equation. So this is a solution of our equation, and this is a solution of our equation. We have two formulas. These two formulas can be combined in one formula, where capital A is any real number. In particular, if capital A is 0, we get this, because 0 times E is 0. If A is not equal to 0, we get this, because plus minus E to C can be any non-zero real number. Was that a question?
Yeah, that was exactly what I asked. Thank you.
Any other questions?
Yes, so at the very bottom, you used this method, and then a little above it, you use the C exponent. So here the C doesn't have positive plus or minus. So if
But
you
here there is no plus minus either.
Okay.
It's same. It's totally same. We just use a different letter. Instead of a lowercase c, we have uppercase A.
All right.
This is fundamentally same. Here, a lowercase c is any real number. Here, uppercase A is again any real number.
Oh, okay. Thank you.
Any other questions?
For you said you explained how integrating both sides is a non-trivial step. Could you explain how what conditions need to be satisfied for that to be always to be held true, where you can integrate both sides?
So question is, how come that we jump from here to here, correct?
Right.
Well, one way to think about it is the following. If you go back to this, move y to the left, we will get y to -1, y prime is equal to x squared, correct?
Right.
Then, let us integrate both sides by x. The right-hand side will be this. It will be integral of x squared dx, correct?
Mm-hmm.
The left-hand side will be integral of y to -1st power times y prime dx. Agree?
Right.
But now, let us go back to calculus. Take a look at this. The substitution rule. Please take a look at what is written here. If we have f of g of x, g prime of x dx, it is same as integral of f of u du, correct?
Okay.
Now, in our case, remember what we have on the left. We have integral of y to -1st power y prime dx.
Right.
If you think about this, in our case, g of x plays a role of y.
Mm-hmm.
Instead of g, just put y. F is -1st power. So this is y to -1st power. This is y prime dx, which can be written as y to negative first power dy. Done?
First power dy.
Well, yes. I know it's a little bit confusing. So once again, remember, here we have integral of y to negative first power y prime dx, correct?
Right.
So in this formula, think about g of x as about y of x. In other words, just replace g of x by y. You follow me?
Yep.
So we'll get f of y times y prime dx, right?
Okay.
So once again, if g of x is y, this formula becomes f of y prime dx, right?
Okay.
Correct? Now question is, what is f in our case? But remember, inside integral, we have y to negative first power y prime. So in our case, since we have y to negative first power, y to negative first power is a composition. And over here, we have a composition of two functions, correct?
Yeah.
Y to negative first power is a composition of two functions. The inner function is y, f is x to negative first power.
Okay, yeah. Compass with y, yeah.
Correct? Composition, if we combine x to negative first power, if we combine this with y, we'll get y to negative first power, right?
Mm-hmm.
Correct?
Mm-hmm. Yep.
And now, note that the jump from here to here, we denote g by u. In our case, g is y, all right?
Right, okay, I see.
So the whole thing becomes integral of f of y, but f is x to negative first power. So the whole thing becomes y to negative first power, right?
Yeah, okay, I see that.
And this is dy. Done.
All right. Okay, that makes sense. Thank you. Also, quick question on like the whole method of integrating factors. So when we calculate mu, the only reason why when we integrate we don't account for the constant is because we're kind of picking mu, right?
The reason why here, let me pull up a particular example. The reason why here we do not put plus c is the following. We want to find mu such that we multiply both sides by mu and the left-hand side becomes this. Note that this mu without any c perfectly serves the goal. Done?
Okay.
So you can put plus c, it's just a redundancy.
I see. Yeah, okay. Thank you.